All right, let's look at finding x-intercepts and the multiplicity of the intercepts. So x-intercepts and multiplicity of the x-intercepts, what they're going to do when we're graphing higher degree polynomials is tell us what happens in the middle. Remember, end behavior told us, okay, this is what happens at your ends. You're going to look like this. But we had no idea what was going on in the middle here, right? Well, the x-intercepts, the y-intercepts, they're going to give us that information. So how do you find an x-intercept? Well, recall, in order to find an x-intercept, what you need to do is you need to set the function equal to 0 and solve for x. Now notice I said to find x-intercepts or zeros, right? We're going to start calling x-intercepts zeros from now on. And the reason that they're zeros is that they happen when the y value is 0. So they're called zeros of a polynomial. Zeros and x-intercepts are going to be interchangeable right now. Well, x-intercepts we're at least used to finding, right? You set the function equal to 0, you solve. How do you do that? You're probably going to have to factor, use the quadratic formula, lots of different other ways, but we're going to be using those things that we learned back in the previous sections. All right, well, what about multiplicity? Well, what is multiplicity? Multiplicity might be something new for some of you guys. Well, multiplicity, what that means is the number of times a number is a 0 for your given function. So how many times is that a 0? Let's say that I ask you to solve, all right, well, x minus h raised to the k power is equal to 0. Well, what that means is that h, this h here, is going to be a 0 for this polynomial with a multiplicity of k times. Well, let's explain that a little bit as well. So let's say that I have x minus 1 is equal to 0. If I solve for x, I get that x is equal to 1. Well, what is the multiplicity of this thing? So that means how many times was this a 0? Well, is this raised to any power? No, but I could always raise it to the first power if I wanted to. So this is going to have a multiplicity of 1. Well, let's change it up again. What if I had x minus 1 squared is equal to 0. Well, if I solve this, and I'm going to solve this maybe a little differently. Typically, I would probably take the square root of both sides to solve this, but let's say I don't do that. If I were to set each factor equal to 0, remember x minus 1 squared is the same as x minus 1 times x minus 1, so then you're setting both of these equal to 0, you're solving both of them, and for both of them, then you get x minus 1. So you have to ask yourself, how many times was x minus 1 an answer for this polynomial? Well, twice. It's an answer twice. So it has a multiplicity of 2. So going back to this tells me I have a multiplicity of 2. So again, x minus h raised to the k power equal to 0. Notice that all these things are being equal to 0. Well, that tells me that h is going to have a multiplicity of k. So multiplicity again means just how many times your number is a 0, is a solution, is an x-intercept for that function. All right, well, why does that matter? What do we care how many times? Well, the reason is different things happen depending on the multiplicity of your 0. So if you happen to have an odd multiplicity, so if your 0 has an odd multiplicity, so you have a multiplicity of 1 or 3 or 5 or 7, etc., then the graph of your polynomial is going to cross the x-axis at that number. For example, here we had a multiplicity of 1 for our x-intercept of 1. Well, what does that mean? At 1, my graph crosses. It goes from above to below or below to above. It'll cross the x-axis at that point. All right, well, what happens if I have an even multiplicity? Well, if your 0 has an even multiplicity, then what's going to happen is that your function's going to bounce at that number. Well, what do I mean bounce? Well, that means it's going to touch at that number and turn around. It's going to touch and just go right back the way it came. So if you have an even multiplicity, you bounce. If you have an odd multiplicity, you cross. Here's an example of a graph where we have two x-intercepts. Here's your x-axis, and notice we're crossing the graph here at this point at x equal to -4, and then here at this point at x equal to 1. Well, those are my zeros. Those are my x-intercepts. But it appears that x equals -4 has an odd multiplicity. Well, how do I know that x equals -4 has an odd multiplicity? Because if we take a look at x equals -4, notice that we cross. We go from one side of the x-axis to the other side of the x-axis at that point. So because I go from one side of the x-axis to the other, since I cross it, I know that I have an odd multiplicity. Well, over here at -1, if we look closely, I have touched and turned around. So what my function does at 1 is I touch it, and then I go right back in the same direction that I came from. So I know that I have an even multiplicity. So when you're odd, you cross the x-axis. When you're even, you bounce. Well, let's talk about finding the y-intercept next, and then we're going to try to graph one example in this video and then save the other 3 for the next. Finding the y-intercept is going to be the easiest thing, and we're going to continue to do this for everything else that we graph in this class. So finding the y-intercept, you're going to love it because it's super easy. How do you find a y-intercept? Well, the y-intercept, again, it's going to tell us what happens in the middle of the graph, just like the x-intercepts and their multiplicity. But y-intercepts are really easy to find. How do you find y-intercept? Compute f of 0. Remember, that's a function value, so that says put a 0 in place of all the x's in your function and then just simplify. So every time from here on out, you're finding y-intercept, really easy. Find f of 0, there's your y-intercept. Okay, well, let's look at example 5 here. Example 5 tells us to graph the polynomial function, and then we want to identify the end behavior, the x-intercepts and their multiplicity, and then the y-intercept. Well, remember, how do you find end behavior? Well, end behavior depended on your leading coefficient and your degree. So, is this all completely multiplied out? Yes. How do I know that? There's no parentheses in there, nothing to multiply. I'm good. I need to find the largest exponent. Where's the largest exponent? Well, it's right here. It's 3. Well, 3 is odd, so the degree of this function is odd. What about the leading coefficient? Well, the leading coefficient is going to be the number in front of the variable with the largest degree. Well, there's no number in front of x. You know that that means that it's a 1. Well, 1's a positive number, so my leading coefficient is positive. So now I need to remember, all right, what happens with an odd degree and a leading coefficient that's positive? Well, odd goes opposite, so they both start with O. Hopefully that helps us. Odd goes opposites, down left and up right. So again, whenever you see the word odd, you better have 2 things going in opposite directions. Second, find your x-intercepts. Right, how do I find the x-intercepts? You take your function. My function happens to be x cubed minus 9x. You set it equal to 0, and you solve for x. Well, how do I solve x cubed minus 9x? Well, the first thing I need to do is probably factor. So can I factor this? Well, there's 2 terms, and they have a GCF of x. So if I factor out my x, I'm left with x squared minus 9 equals 0. Well, let's set each one of these equal to 0 and let's solve them. I have x is equal to 0 and x squared minus 9 is equal to 0. Well, do I need to solve the first one? No, it's already solved. What about the next one? Do I need to solve it? Yes. First, move 9 to the other side. I get x squared is equal to 9. You take the square root of both sides to solve this, and then x is equal to plus or minus 3. Remember, when you take the square root of something to solve it, it's equal to plus or minus 3. So I have 3 different x-intercepts. I have 0, I have 3, and I have -3. Well, now I need to figure out the multiplicity. So how many times is 0 a solution, an x-intercept, for this function? So I need to find its multiplicity. It was only a 0 once, right? Because if I look there, I can raise x to the first power, which means that I have a multiplicity of 1. Well, then 3. What's the multiplicity of 3? And this is where it gets a little tricky. I solved it this way because most students will, but do you agree with me that I could have taken this problem right here, the x squared minus 9 equals 0, and factored it? Yeah, that's the difference of squares. What does that factor as? X minus 3 times x plus 3. Then I set each one of these equal to 0, and I solve them both. And what do I get? X is equal to 3, and x is equal to -3. So, doing it this way, what is the multiplicity of 3? Well, again, when I'm equal to 0, I can put a 1 there, right? Which means that x minus 3 occurs once as a factor for this, so my multiplicity for that is 1. What about x plus 3? Well, again, here I'm equal to 0. I could have set it raised to the first power. So it occurs once. My multiplicity for -3 is 1. Students get confused when they look at something like this. And I'm going to write this down and erase it, so you may not want to copy this. But x squared minus 9 equals 0. And they think, oh, there's a square there, that means I have a multiplicity of 2. No. Why no? Remember, I said it has to be x minus h raised to the k equals 0. Well, do I have one whole thing raised to a power? No. All I have is x raised to a power. When I move 9 to the other side, am I now equal to 0? No, I'm not equal to 0. So when you're doing this, just because you have a square doesn't mean you have a multiplicity of 2. Only when you have a factor like this raised to a power and equal to 0 will you have a different multiplicity. Let me erase this, and then we're going to find the y-intercept, which is next. So the y-intercept, what's the y-intercept? Well, the y-intercept, that's the easy part. We compute f of 0. Well, again, what does that mean? That means everywhere there's an x in my f of x, instead of writing x, I want to write 0. So let's see. I'm going to erase that so we can see our function better. Instead of saying x cubed, I'm going to say 0 cubed minus 9. Instead of writing x, I'm going to write 0. Well, what is 0 cubed minus 9 times 0? 0 minus 0, which is just 0. So my y-intercept here is 0. Right? Y-intercepts are going to be the easiest thing from here on out. They're computing f of 0. Well, I told you you needed all of this in order to graph higher degree polynomials, but I didn't really tell you how to put it all together. So let's talk about what to do in terms of putting it all together. Thing number 1 that you need to do, and maybe let's see if I can fit it right in here for you guys. So steps to graph. So the first thing you want to do is plot all your points. So plot all your points. All right, well, what points did I have? I have the point 0 here. I have the point 3, 1, 2, 3 right there, and I have the point -3, -3 on the other side. And I have a y-intercept of 0. Well, that's the same point as the x-intercept of 0, so I don't have to draw that point twice. So first, plot all your points. Step 2 is from the far left point and far right point, draw your end behavior. And I'm just going to write BEH for behavior because I'll run out of room. So from the far left point and the far right point, draw your end behavior. All right, well, what does that mean? Well, where's the furthest left point that I have on this axis? Right here at -3. So from this furthest left point, I have to look just like my end behavior on the left. Well, my end behavior for this particular function goes down. So from this furthest left point, I have to go down. Then I have to figure out what I do from the furthest right point. Well, which one's the furthest right point? It's right here at +3. Well, what happens to the very right of this graph? I go up. So from this point, I have to go up. So again, first plot your points. Then from the furthest left point and the furthest right point, you plot your end behavior. So our third step is that we're going to connect the points in the middle using our multiplicity. So we're going to connect the dots in the middle using our multiplicity. What am I talking about? So remember, if you have an even multiplicity, you bounce at that point. So if you're coming in from the bottom, you bounce, you go back to the bottom. If you're coming in from the top, you bounce, you go back up. If you have an odd multiplicity, you cross the x-axis. So if you're from the bottom, you go up. If you're from the top, you go down. So we need to figure out what we do here. So what kind of multiplicity did each one of these have? Well, each one of them had an odd multiplicity. Well, what does that mean? That means I need to cross the x-axis at my 0 of 0. I need to cross the x-axis at my 0 of 3. And I need to cross the x-axis at my 0 of -3. Let's look at that. So let's go left to right. We read left to right. We write left to right. So let's just graph left to right. So let's all start on the leftmost point. It's here at -3. What was I supposed to do at -3? I need to cross the x-axis. So I need to go from below, which is where the end behavior tells me I need to go, and then go up. But I have to play connect the dots, right? Connect the dots. Got to connect my points. So I have to turn around and go to my next point. Now, how far up I go, how close to the x-axis I stay, you need calculus for that. So when you look at your classwork answers, they're going to be accurate. Why? The computer knows calculus. So Just be aware that I'm not looking for perfection there. I'm making sure that you're crossing the x-axis when you need to, you're bouncing when you need to. So as long as you have the general shape, you're good. So again, I don't care how far up you go. I don't care if you go this far up or just stay really low. That doesn't matter to me because you need calculus to figure out where you're going. And I'm not teaching you calculus outside of the scope of this class. So what you need to know is just use your multiplicity. I'm supposed to cross, I cross, but intuition tells me I gotta go back down, so I gotta get to my next point. All right, I'm at my next point. What is it? It's 0. What happened at 0? Well, my multiplicity is 1. I need to cross. So if I'm above, which I am, the x-axis, I need to get below it. You cross because your multiplicity is odd. But again, we play connect the dots. So from this point, I gotta go up to the next point. Okay. Well, what am I supposed to do at that point? What point is that? Well, that's 3. I need to cross. Did I cross the x-axis? Take a look at this. Did I? Yeah. My end behavior told me I was going up the other way. So perfect. We did it right. Again, this is the sketch of x cubed minus 9x. It's not perfect. Why? Because we don't know calculus. We don't need to know calculus outside the scope of this class. All we know is that our end behavior says we need to go down on the left, up on the right. All my multiplicities were odd, which meant I was going to cross everywhere. I had 3 zeros and I crossed. And notice, smooth, I could have drawn this without picking up my pencil, and I have no sharp corners or turns. All right, the next video we'll do 3 more of these graphs.